All right, in this video, we're going to be doing something that's kind of like the opposite of what we've been practicing in class, which is graphing trig functions. In this question, we've already got a graph for a trig function. It's our job now to actually determine what the function is. So determine the function given the graph. So reverse. All right, so let's read the question. This graph is a function in the form y equals a sine b of x plus c plus d. Notice that there is a difference between the function that's given here and the function that we've been working with. And the difference is that the top function is just written in a different form. And we call it factorized form. And ours is non-factorized. So what's the difference? Well, not a whole lot, except that our b value, when we use it, is inside the bracket. And when it's inside the bracket, we just need to use different rules, a couple of different rules. Namely for b and c, we just use a different rule. And we should already know them, but if we don't, to find out what c is, it's c divided by the b value now, when it's in non-factored form. And when we want to find out b, it's simply 2 pi divided by b. But we can go ahead and just use this. We've been using this in our class. So we can do that, that's fine. All right. Now, when we go ahead and try and figure out a function for a graph, most of the information we can just derive from the graph itself, just by inspection. Sometimes there's a couple of formulas we can use, but a lot of what we do will just be observation. So let's go ahead and try and figure out the function. Step 1, I would recommend finding the vertical components of this graph. And that is this, the amplitude, right? The distance between the top and the middle, right? Or the distance between the bottom and the middle. That's the amplitude there, that distance there, all right? So we're going to find that. And then straight away, we're going to find the d value, which is how far this particular function has gone down, or how far this particular function has gone up. So we're going to find both of them at, roughly at the same time. And then we'll deal with the horizontal components next. So let's do it. So our a value, now to figure out our a value, we're actually going to find out the absolute value of a. That just means no matter what that distance is, right, between the top and the midpoint, roughly, whatever that is, it's always going to be positive. And that's what these two lines are. It just means we're going to always look at the positive number because it's kind of just like a distance. And the way we work that out, we use I suppose you could say like a little bit of a formula here. And what we do is we write that we want to find the maximum value, which is here, right? That's the maximum. And to that, we take away the minimum, which is this. And from there, to find out halfway in between those two, we divide by 2, and that gets us the midpoint, right? So let's go ahead and do that. We'll substitute. And remember, we're finding out how far up and down on the y-axis, not how far across. It's actually how far up and down. So at this point here, the maximum is 1. So it's 1, take away, and then our minimum here, right? That is -3. So it's 1, take -3, divided by 2, and that is, 1 plus 3, that's 4. 4 divided by 2 is 2. So now we know our a value is 2. I'll just go ahead and just write that underneath our original function. All right, done. So that's the distance between the top and the midpoint, or the bottom and the midpoint. Do you think you could work it out already, just quickly, how far this graph has shifted from the original sine x function? Well, we can have a chat about it later, but we'll move on to D. So let's work out D. Well, how do you do that? Oh, let's not use our laser. the d value, or how far it shifted, what we can do is we get our maximum and we add it to our minimum value. And that'll tell us, well, let's divide by 2, and that will tell us how far it's shifted, right? The actual value, how far it's shifted. Here we go. 1 add -3 divided by 2. And so that'll be 1 take 3. So that'll be -2. -2 divided by 2 is just -1. So that value there means that our function has shifted down 1 compared to, right, let's just write this, make sure we understand. This is compared, in fact, all of our letters are compared to sine of x, right? And so if we have a look quickly at sine of x, right, sine of x would just look like this. Let me go ahead and use black. So this is all in comparison to sine of x. Okay, kind of like that. If I wanted to show more, I guess I could do it like this. Hold on. Like that. And so our period would be 2 pi, and don't forget that sine of x, it always starts right there at the midpoint because it goes back down again, right? So that there is the midpoint, and here the midpoint is 0. So thinking about this, if we know that we have a vertical shift of -1, well, we know then that our midpoint is at -1. So let's draw our midpoint. And that's pretty straightforward, right? Let's go ahead. I'm just going to draw it there. Well, let's just make it a little bit more accurate. Third time lucky. Fourth time lucky. I really want it on -1. All right, I'm happy with that. It's just below -1, but I'm happy with that. So does this make sense? Does this -1 make sense with what else we have found out, i.e. our amplitude? Well, it does, because if you think about it, our amplitude is the distance from the top or the bottom, but we'll go with the top here, to the middle. There's the middle, and our amplitude there, the distance is from 1 to -1, and so that's 2. And that makes sense. That's in line with what we expected for our d value, because our d is -1. So this and this support each other. All right, now we've found A and D, we can go ahead and move on to B and C. All right. So let's go ahead and do it. To find out B, well, we're going to find let's use green. We're going to find the absolute value of B, right? B being the phase shift, or not phase shift, the horizontal expansion, or the period, right? We'll call it period. And it's simply 2 pi divided by, well, B. Oh, I guess we'll call it the period, okay? And so in this particular case, the period being the distance between 2 troughs or 2 peaks, right? This here is just the distance between this and the next peak, which we can't actually identify. So what about 2 troughs? It's a bit hard to tell where that trough would be. So what we'll do is we'll just kind of, we'll use our logic and just determine that the distance between this and this, so that and that is that there. And the distance between a peak and a trough is just half the distance between 2 peaks or 2 troughs. So whatever this distance is here, we'll just times that by 2, and that'll give us the extra bit, which will determine our period. All right. So at the moment, this is 11 pi on 6, and we need to go to, yeah, it's there. It's 5 pi on 6. So what's that distance? 11 pi on 6 minus 5 pi on 6, and that'll give us the difference, which is in between. That'll be 6 pi on 6, right? So I'll write that down. 2 pi on 6 pi on 6. Now the 2 6's cancel out, but we need to multiply by 2 because we have, remember, only a peak to a trough. We're going to times that by 2. So we'll do it there, and it'll be 2 pi on 2 pi, which is equal to 1. And so our period is 1. Therefore, we know our period is 1, right? Our B value here, that's 1. Oh, we know our D is already, what do we work it out to be? -1. And so we're really close. We're just going to find out what C is. What's our value of C? All right, C is, I suppose we can write C, which is our phase shift. So phase shift. Now, phase shift is fairly straightforward. If we just consider what where a sine function starts, well, the standard sine x function, it always starts at this point here, which is actually, if you think about it, it's the midpoint, right? A sine function starts at the midpoint when you're at 0, okay? So we're going to assume it's the case with this function here. But as you can see, there's the midpoint. And so what we do is we go to the midpoint on our y-axis, right? Not there, but we go to where the midpoint is on our y-axis, right there. And then we basically say, well, if the midpoint is where the sine function starts, how far did the actual line, right, this line, how far did it actually move across? And it moved across, can you see it? On the x-axis, it moved pi on 3 that way, right, to the right. And so when something moves to the right, our B value is negative. And how far did it move? Well, it moved pi on 3 to the right. So pi on 3 to the right. And when something moves to the right, it's a negative. So therefore, C equals negative pi on 3. So I believe we just about have everything. Yeah, we really do. So we can go ahead and write it, and that will summarize our video here. And so to find the equation, we just write it. So therefore, y equals 2 sine of, here we go. Now our B value is just 1, so it's just x minus pi on 3 because we moved to the right, and then minus 1 because we shifted down 1. Thank you.